DroidUp just introduced its Moya AI robot with several world-first tech features. So today on AI News, we're taking a closer look at what tech is inside, what it can do, and more for you to decide if it's worth the price. So first, let's take a look at what this video presents. It says that it features thermostatic silicone skin and 40 sets of facial muscles and a 30-kilogram form factor with high precision interaction, 100 degrees of freedom throughout its body, and full body tendon drives. And it says here that this is the first completely bionic robot. Comment down below if there has been anything like this before. Here it's purporting this as a house partner with whole body tactile perception as the baby asks for the robot to hand over its toy. It says that it also understands language and guarantees safe interaction. Then in this next clip, it's working as a partner to this woman. It says that it features something like an amygdala for emotional understanding and a deep sense of situational awareness. Here it tells this woman to take a rest because she's been working for an hour. Next, it acts as a well-being partner for the elderly. After giving this woman a drink, here it's walking up to this grandma and asking her to tell it a story about when she was young, apparently using the Droid Soul intelligence engine, which the company says not only understands thoughts, but also takes the initiative to accompany you. And the three use cases are being a wellness partner, a work partner, and a house partner for children. But now let's get down to the physical structure of the Moya. It stands 165 centimeters tall, or about 5 feet 5 inches, and weighs 32 kilograms, or about 71 pounds. And its skeleton platform is actually using the upgraded Walker 3 bipedal skeleton. So this is a modular design that allows for the appearance and gender traits to be customized. And in terms of body materials, it features high-grade silicone that is layered on the exterior over a simulated rib cage and lightweight lattice of muscle materials that mimic fat and soft tissue. Then when we get into mobility and performance, it walks at a speed of 0.83 meters per second, which works out to about 3 kilometers per hour, or about 1.9 miles per hour. And it features a battery life of about 6 hours while walking, with its actuators using energy-efficient tendon-assisted electric actuators. But it's noted that this is optimized strictly for flat indoor surfaces, and it's not capable of high-impact athletics like running or jumping. And when it comes to social sensors and expressiveness, its face articulates 40 degrees of freedom with these micro actuators, featuring 100 degrees of freedom throughout the body, and it can make real-time micro expressions like smiling, blinking, winking, frowning, eyebrow raising, nodding, and blushing. And its perception array is powered by dual high-definition cameras that are built in directly behind its eyes, that are paired with a facial tracking system for real-time human micro-expression reading. Then when it comes to the processing and AI, it's using a motor control architecture that is proprietary to DroidUp. It's their cerebellar motor control model, and this splits tasks simultaneously between dynamic bipedal balance and biomimetic facial blending. And they also use a communication layer which integrates speech recognition and natural language processing for unscripted multi-turn dialogue, but the LLM being used is still undisclosed. And the market launch window is aiming for late 2026 with a starting price of approximately 173,000 US dollars. This is from DroidUp, which is a Shanghai-based startup that was founded in 2021. So leave in the comments down below if you think that this robot would be worth it. But researchers from Beijing Institute for General Artificial Intelligence and Unitree Robotics are also pushing the envelope of realistic robots with the unveiling of OmniXtreme, a general motion control framework that allows humanoid robots to perform acrobatics using a single unified algorithm. In fact, this breakthrough effectively breaks the generality barrier, which is the engineering bottleneck where training a robot to learn new movements causes its overall tracking accuracy and balance to collapse. So unlike other models, OmniXtreme uses a distinct two-stage architecture, with stage 1 being flow-based pre-training, where individual expert policies are first trained on single, precise movements, and a high-capacity flow matching policy then distills those separate skills into one central base brain in simulation. And then stage 2 is actuation-aware post-training, where a lightweight residual policy is layered on top to make real-time corrections. And during real-world deployment on a Unitree G1 humanoid, OmniXtreme achieved an unprecedented 90% success rate. And to achieve the next level of dexterity, researchers from UC Berkeley, Nvidia, and Stanford just unveiled T-Rex, an open-source tactile reactive AI framework that closes the gap between robot dexterity and human touch. Because while modern vision language action models excel at visual tracking, they remain largely numb, making them prone to crushing or dropping things. But T-Rex solves this problem by introducing a variable rate architecture that processes high-frequency haptic signals in real time alongside standard planning streams. And the main innovation here is a specialized mixture of transformer experts design, because real-world dexterity requires two operational speeds, with vision and language processing environments at a slower pace while fingertips must adjust to forces in milliseconds. The first of these is a low-rate action expert handling baseline visual motor planning and course trajectories. Then, simultaneously, a high-rate tactile expert uses an encoder to compress fast-changing touch data into digital tokens, which allows the model to calculate split-second grip adjustments to prevent slips. And in generative AI, Midjourney just pivoted into healthcare hardware with the launch of Midjourney Medical and its flagship Midjourney scanner. And this is designed for rapid full-body imaging, and it relies on a proprietary process called ultrasonic CT, which uses harmless sound waves in water instead of ionizing radiation or intense magnetic fields. And during a scan, the user stands on a platform that descends through a pool of water. Then they pass through a ring that houses roughly 500,000 sensors which transmit ultrasonic waves from multiple continuous angles, and a compute cluster running over 2 petaflops of processing power then reconstructs these echo signals into detailed 3D cross-sectional maps of bone, muscle, fat, and internal organs in under 60 seconds. And this hardware is intended to debut in San Francisco by the end of 2027, with outputs being strictly limited to non-diagnostic body composition maps for tracking wellness trends. And Midjourney plans to use data from these commercial runs for further regulatory submissions, aiming to deploy 50,000 scanners globally by 2031 in order to achieve a capacity of 1 billion preventative scans per month. Anyways, if you want more on the latest in AI and robotics news, like and subscribe and check out this video here.